Now we talked about the joint method to analyze simple trusses. Now, let's talk about the second method. It's called the sections method. Okay, and you can use either method, right, to calculate the forces in a truss. Okay, forces in a member. But this section method has a slight advantage over the joint method when you're asked to find the forces in only a few members. Okay? Now, if you're asked to find all the forces, okay, in the entire truss, then joint method, and the previous method, might be a little better. But in this example right here, you're asked to find just these three forces. Okay, F in BD, BE, and CE. Just three. I don't really care about the rest. So in this case, section method might be a little faster. Okay, but joint method, of course, will still work, right? But this method might speed things up a little bit. Okay, let's see how this works. Now, this should look quite familiar. And from the last video, exact same truss. Okay. Now, I have a concentrated load of 200 newton, okay, coming down from joint E. Now, each section, okay, across the bottom chord as well as the top, is 1 meter long. Okay, and the slanted members are at 45 degrees. Here, you're asked to find only these three forces. Okay. Now, you recognize that these three members, BD, BE, and CE, they kind of lined up, right? BD is here, BE is here, and CE is here. Okay, so they're kind of here in this box right here. So for sections method, what you do is you make a line, okay, that cuts through the middle of your bridge, that sections through all the unknown forces. Okay, section through the members, okay, where you need to calculate the forces. So in this case, it's these three. So I'm going to do a cut, something like this. Okay. So I've sectioned through this truss, right? So I have this left half and right half. Okay. So next, what you do is you take the half that typically is smaller, okay, and also the half that has some known force or forces. Okay, in this case, let's say I have 200 newton here coming down the middle, but let's know the only known force. This truss is symmetrical. This means that immediately you know these two reaction forces, 100 pounds, 100 newton coming back up at joint A and then at this other joint. Okay, so in this case, whichever half should work, right? But just to make things easier, I'm going to pick this left half because it's just a little smaller. Okay, so the next thing you do is draw that half, that part of the section that you have just chosen, and throw away the other half. Okay, so just focus on this left section right here. So I'm going to draw that. Okay, so A, B, C, and then a little bit of BD, a little bit of BE, and a little bit of CE. Alright, because I've just sectioned through. Okay, so this is now my free body diagram. Okay, so this is the structure that I'm going to analyze. Okay, and the unknowns, these three guys, are in here. Okay, so this is my F, B, D, this is F, B, E, this is F, C, E. What about directions? Well, at this point we don't know the directions. We really can't really figure out, okay, real quick anyway. So Once again, if you don't know something, assume something, and you'll be okay. Alright, trust me, you'll be okay. So assume a direction. So let's say, I'm going to assume it, right, this goes this way, and this goes up, and then this goes to the right again. I'm just going to assume direction. Okay? Alright, so these three are the unknowns. And I have this guy right here. This is 100. I do know that. And that's it. This is your free body diagram for this whole structure. Okay? So this whole free body diagram has three unknowns. Okay? One known. And that's it. The other forces, let's say FAB, FAC, and FBC, they don't appear in this free body diagram because those forces now have become internal forces. Okay? So they're internal to this structure, to this free body diagram now. That's why I don't care about them, because they're internal. On the contrary, FBD, FBE, and FCE, and this 100 Newton, they are external forces. Okay? That's why this free body diagram will work. Right? Because it involves these three unknowns. Okay. So, let's focus on one force at a time. Okay, using the same section, exact same section. Except I'm gonna draw that 3 times. Okay, 3 exact same sections. Okay, and I'm gonna calculate these 3 forces separately. Okay. Now, before I begin, just notice that this FBD, FBE, and FCE, it actually extends through here, okay, through this little leftover section, okay. So, because they're all force vectors, right? So this picture right here is equivalent to looking at only this little triangle. That's it. Okay? You can essentially throw away these 3 little leftover pieces, okay, of the members. And then you draw all the forces. This is known, and these 3 you can just sort of draw it from here. Okay? Because they are forces. This FBD actually begins from this joint B. Right? So they're exactly the same thing. So do it this way to FBE and FCE. Okay? So now this free body diagram is a little easier to visualize, okay, than this. Okay? Just throw away the leftovers. Okay? And I think it just keep it clean. Alright, so let's look at this. Let's throw away this guy now. We don't need this. I don't need this either. Alright. Okay. I'm just going to redraw everything. Alright. So, let's just keep one triangle, this ABC triangle, alright, my free body diagram up here, okay, as a reference. I know that this is 100. Goes up for sure. These 3 guys, again, I'm going to call it FBD, FBE, FCE. Okay. I'm going to keep this as the real, the actual picture, okay, where the actual direction will be drawn as soon as I've actually figured out the actual direction. Okay? So, keep that there as a reference. Now, let's begin. The first force. Well, just draw the first diagram. And draw it up here. Right. Again, ABC. 100. Now, here I can draw my assumed direction. FBD, FBE, and FCE. Okay. Pick any force you like to begin with. let's say I'm gonna first calculate. Let's pick the easiest one first. So I can do FCE. Okay, so let's do FCE. Okay, this is my free body diagram. I have 4 forces total. Okay, 3 of them is unknown. But how do I eliminate the other 2 so that I can find this FCE? Okay, now at this point you might be thinking, okay, what I told you before, in joints method, you pick a joint with no more than 2 unknowns. That's because we only have 2 equations to work with, right? Some forces x equals 0, some forces y equals 0. So 2 equations, 2 unknowns. Right? So mathematically, you have to satisfy the requirement. But here, what's going on? We have 3 unknowns. Well, the answer is we don't use these 2 equations at all. We don't have to. Instead, recall equilibrium conditions for rigid bodies. Other than satisfying these 2 equations, we also have to satisfy sum of moment equation. Okay? So now in section method, this is the equation that you'll be using over and over and over. Okay? So sum of moment, okay, of the entire free body diagram about any point, some point, set equals 0. Okay? Let's do that. Sum of moment from all these forces, all these 4 forces, about some point. Oh. The most important question here is about which point. Here's the trick. You pick a point where a lot of forces pass through. In that case, those forces will create no moment. Okay? The moment, it will be 0. Okay, from those forces because they pass through that point. Okay, so in this case, look at this. I have these 2 forces, FBD and BE, both passing through this joint B. Okay, so maybe I can sum the moment about joint B. Okay, and that's 0. It has to be 0, okay? Because this is one of the equilibrium conditions. Okay, so some moment about any point it has to be 0. Just that I pick joint B. The advantage is these 2 guys, these 2 unknown forces, disappear right away. They don't appear at all in this equation. Okay, because recall, moment equals R cross F, okay? And the magnitude of moment equals force times this R, okay, in terms of magnitude would be D, the shortest distance between the force, okay, between the line of action of the force and the point, whatever point that you choose. Okay? So let's apply this equation to this entire free body diagram and see what happens here.